Hello, today we're going to explain 2's complement, which is a way to represent negative numbers in binary notation. Okay, so if you know a bit of binary notation, let's go review it. Positions are represented by, numbers are represented by zeros or ones, where starting from right to left, this position reflects 2 to the power of 0, so 1. This would be 2 to the power of 1, so the 2's, 2 to the power of 2, so that's 4, 2 to the power of 3, so that's 8. So number 1 would be a 1 in this position, number 2 would be a 1 in this position, number 3 would be a 1 in the position of 2 plus a 1 in the position of 1, etc., etc. Okay, so you can basically find the binary number, the decimal number of representation of a binary number just by finding which position, for example here in 6, which positions are with a 1 and adding those up. So 2 to the power, this is 2 to the power of 2 times 1 plus 2 to the power of 1 times 1, and that's 4 plus 2 equals 6. Okay, so that's very easy. The problem is, how do we represent negative numbers? So the first thing that people thought of was to remove one of the bits, one of the positions, and use that bit as a sign bit. Okay, so then if we did that and we used the sign bit, then we could have the same values for the positive ones, because that wouldn't change, so that wouldn't change, and then the negative ones would be with a 1, and then we would just start adding them up as we did with the positive ones. One, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Okay, so this leaves certain. So what would we have here? This would be the same numbers as the positive ones. So these ones would be basically the same, but here we would have a strange thing, because this would be a minus 0. Okay, so we have a plus 0 and a minus 0, which is strange. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So we have plus 8. So no, here we would have plus 7 would be here, and this one would be again the 0, the minus 0. Okay, so this one we wouldn't be able to use. So we lose the range, we can't represent now from plus 8, from 0 to plus 8, we can only represent from minus 7 to plus 7. Okay, but we have that. The problem is that is when we try to add numbers. For example, if we try to do minus 2 plus 2, that should give us 0. If we do that in a binary, minus 2 is this one, and plus 2 would be this one. So if we do 0 and 0 is zeros, 1 and 1 is 2, so we carry 1. 0, that's a 1, and 1 and 1 is 2, we carry 1, which we forget about it because it's out of our range. And then what value is this? To the power of 0, to the power of 1, to the power of 2, so that's a 4. So minus 2 plus 2 would be a plus 4, which doesn't make sense. Okay, so the next thing that they tried to do was what is called the 1's complement. Okay, so in the 1's complement, what we do is positive numbers are represented the same. Okay, the negative numbers are represented just changing the value of the digit for the opposite. So when we have a 1, we have a 0, and when we have a 0, we have a 1. So we would have, instead of 0, 0, 0, 1, we would have 1, 1, 1, 0. Instead of 0, 0, 1, 0, we would have 1, 1, 0, 1. 1, 1, 0, 1. Then we would have 1, 1, 0, 0. 1, 1, 0, 1, 1. 1, 0, 0, 1, 0, 1, 0, 0, 1, and 1, 0, 0, 0. Okay, so this would be 0, 1, 2, 3, 4, 5, 6, 7. Yeah. So then we would have, in the positive ones, we would have 0, 1, 2, 3, 4, 5, 6, 7. Okay. This would be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. And then we would still have a minus 0, which again doesn't make much sense. But this does improve a bit things, because if we do the minus 2 and the plus 2, which we know we have to do 0, if we do the binary 1 addition, we have 0, 0, 1, 0, and if we do this, 1 and 0 is 1, 1, 1, and 1 and 0 is 1, okay, which is negative 0, which is correct. Okay, so this does add up. When we have opposite numbers, we do get the 0. The problem is that if we do 4 minus 2, which would give us 2, we do 0, 1, 0, 0, which is the 4, and the minus 2 is 1, 1, 0, 1. This is 1, 0. Remember that we're doing 1 plus minus 2. And then 1 and 1 is 2, 1 and 1 is 2, and this carryover, which we forget. Okay, so if we do this, this is a 1, so 4 minus 2 is not 1. So that we don't get, we still cannot up, we have improved, but we still cannot add up positive and negative numbers. So the next thing that they tried was what we call 2's complement. Well, 2's complement is, you do the 1's complement and you add up 1, okay? So I'll first write the positive ones. So these ones remain the same. We still have a 0, a 1, 2, a 3, 4, 5, 6, and 7, okay? And then when we're going to represent the number 1, we can first do a first step, which is we find the 1's complement, so we change all the digits, okay, and then we add up 1, so that would be 1, 1, 1, 1. So this one is really negative 1, okay? If we want to do this one, we would first do the 1's complement, so that would be 1, 1, 0, 1, and then we add up 1, and that would be 1. So when we add up 1 here, 1 and 1 is 2, 1. So we get 1, 1, 0, 1. So we get 1, 1, 1, 0. And that would be minus 2. Okay? Let's change the color here so that we can see it better. So that's minus 1, and that's minus 2. There's a faster way to change into positive, and from positive to the 2's complement, which is start from right to left and keep your first one. So for example, in 7 we would keep no, let's go in order. Let's do, we've done number 1, 2, that's number 3. Okay, so number 3 is this. We want to find the 2's complement. Okay, so we keep this first we keep the first one that we find, so we keep this one, and then we change all the other digits. Okay, so number 3 would be 1, 1, 0, 1. That's -3. Okay, so we can do that with all of them. Follow me. I'm going to do number 4. The first one is in this position. Okay, so we're going to keep everything until that position, and then we change the other one. Okay, so we go from right to left until we find the 1, keep everything until we find the 1, and then change everything else. So if we go to 5, the first one is this one here, okay, on the right. So we keep those. It's -4. We keep everything until we find the 1. So that's in number 5. It's the first digit is a 1 on the right, and then we change everything else. So everything else would be 1, 0, 1. So that's a -5. Let's go on with the rest. -6, the first one, we copy everything from right to left until we find the 1, and then we change everything else. And then on number 7, the same thing. We change everything else. Okay, so if you see, okay, and then we have, funnily enough, we have still room left for this one, which is -8. Okay, so again, this is 2's complement, which we can do it just by finding the 1's complement and adding 1. Or we can just get any number, for example, number 4 in binary, and we write all the digits from right to left until we find the 1, and then change everything else. And that would be -4. The same can be done the other way around. So if we have -6, okay, we keep all the digits until we find the 1, and then we change everything else. So that is a +6. Okay, if we want to find this one, for example, we keep this and we change everything else. Okay, and that is a +7, a -7, and that's it, a -6. Okay, so from even though the theory tells us that to do a 2's complement, we first do a 1's complement and add 1, there's an easiest way to do, which is to copy everything from right to left until we find the 1, and then change all the other digits. Okay, that's 2's complement. Does this solve my problem about, it does solve my problem about writing negative and positive numbers. We have the positive numbers here. We don't have a -1, and we have here everything from -1 to -8. Okay, so as you see, we have a greater range in the negatives than in the positives, of course, because we don't have to represent the 0. Okay, does it solve the addition? Let's see. So let's see what we were trying to do before, which was -2 plus 2, which was 0. So if we do -2, it's a 1, 1, 1, 0, plus 2 is 0, 0, 1, 0. So that's 0. 1 and 1 is 2. 1 and 1 is 2. 1 and 1 is 2. So that's 0. That's perfect. Okay, and you can see, you can check any other positive and negative number, adding them together, and it will give you a 0. That works out. So that's great. Let's look at any other addition. Let's do 5 plus -3. Okay, so this would give us +2. Let's see. So 5 is 0, 1, 0, 1. Okay, -3 is 1, 1, 0, 1. Okay. So 1 and 1 is 2. That's a 1. 1 and 1 is 2. 1 and 1 is 2. We forget about this one. And this is a 2 plus 2. So that works great again. Okay. So as you see, 2's complement, which is very easy to do, solves adding adding positive and negative numbers, both the opposite ones and any other positive and negative numbers, very easily. We just have to lose one of the bits, which is what we're going to use as a sign bit. Okay, so a 0 is a plus sign, and a 1 is a negative sign. And then if we want to change from positive to negative and negative to positive, we just write the digit from left to right, from right to left, until we find the 1, copy everything, and then change from the first one to the rest to the left, which is change the 1s for 0s and 0s for 1. Okay? I hope this helps.